We can start.
Hey, today we're gonna continue what we have already started yesterday about stimulation and acid job, exactly about what to pay attention to it once you are about or what you are actually doing an acid job. Uh, in fact, we passed through different topics that was including, the roadmap where we identify the problems, and as we have already discussed yesterday, that the stimulation is not like for your problems just by doing like water shut off or by changing the pump design, or there are different solutions that could be done. So sometimes, or most of the time actually, the solution is not stimulation. But if the problem is like the reservoir or the well, we went through the treatment selections, and now we will continue for the sandstone treatment acidizing. I guess we stopped here. For sandstone acidizing, it's really critical, and we need to pick one reaction or the primary reaction, but also we have the second reactions, and if this second reaction will happen, of course, will precipitate unwanted materials. So always remember to remove all the carbonate in near wellbore area, because there is one thing that you never want to have around the wellbore. When you calcium and magnesium are salts of hydrofluoric acid, and they are actually insoluble, and they will create like a lot of damage by precipitating, if we precipitate these kind of salts. And to prevent this, you can have like HCl as a pre-flush, and that use it to like remove all or away from the wellbore. And we do that actually by pumping HCl ahead of mud acid as a pre-flush, usually 15%. And as you can see here in the chart, according to the percentage of carbonate that you have, so you will need a specific volume of pre-flush to remove all these carbonates. It's the injection about 50 gallon per feet, while the percentage is higher than like if the percentage is higher than 10%, so you'd better to treat it as a carbonate rock rather than sandstone, because as you can see here in the chart, the percentage of the volume, that 50. So at that time, you will end up with precipitating insoluble materials, and you cannot actually inject or do acidizing with HF with that a huge amount of carbonate. So we pump HCl to remove all the carbonates as a pre-flush, and then we start our to make the main flush to react with the clays and fines, drilling mud and silicates to improve all the near wellbore permeability. And the thing that HCl works on is that keeps the pH low, and that helps to prevent the second reaction with HF or hydrofluoric. For HF, so it cannot react with carbonate that if it is already existed in the near wellbore area. And then we usually have something we call after flush or over flush, and this will be helpful for displacement of the acid flush away from the well pour area. A couple of recipes that have been proposed that was being used, quite a lot. Okay, so there is no like a standard way of, volume that need to be injected. Okay, but there is, some recipes have been already used and experienced it, and now we're gonna like see some of them. Percent of HF. In fact, it's not being used a lot anymore, but mostly we are using these days about 13.5 of HCl and 1.5 HF, and even less, especially if we have, feldspar around. So we'll go down like a 9 HCl, 9% of HCl, and only 1% of, according to that, you will decide what is the best recipe that you may, prepare. Regarding to the volumes, we can actually have different volumes depending on how badly your reservoir is damaged, and generally the higher volumes with the lower concentrations. And as we discussed, but when it comes to the reality, it's quite difficult to see, like, to know exactly what's the, the depth or the penetration of the depth of skin that you have, and exactly the amount of volume that is needed to be injected. But these are like the volumes is more about like the all the skins and stuff that we're already talking about the damage assessment and skin analysis. Here we have the carbonate formation. The situation is entirely different. The reaction is really simple, because the acid reacts with carbonate and forms 70 bar, and if the pressure over 70 bar, so it remains in the solution. And for the dolomite, is slightly different, but the reaction is almost the same. The principal products is water and C2, and the rest remains in solution. So with the carbonate, we are confident that the reaction is going to happen for sure. So the essence of carbonate acidizing is that you are promoting a formation of wormholes. Like the acid enters into the carbonate rocks and form a little wormhole that can range from like a couple of centimeters into, it could yield up to mines to skin. So when we are talking about sandstone, it won't be stimulation, but if there is a damage, so we're just removing that damage. But when we are talking about carbonates, the situation is entirely different, because we are actually stimulating, we are increasing the productivity, like for sure. It's the chance of success of carbonate is quite like bigger than carbonate reaction. Like there are a couple of things, it's important to know them. The carbonate, what we call it, the reaction rate, and the injection rate, and the diffusion rate. Okay, so the best wormhole that you can have when you get the high reaction rate with low diffusion rate. So at this point, like how, because that helps a lot to get better wormholes and better branches and a good extension of these wormholes. Okay. Here we have the success elements of any acidizing jobs. In fact, there are three main elements that triangle are the selection candidates, and then we have the treatment design and the field operations. So if only one of the three elements was not like well optimized, so the project will not be successful. Generally speaking, for the selection candidates, it's the first priority of the product, so we can increase the production and improve our productivity index. Okay, and then the treatment design is more or less about the service companies, and they know like a lot about what are the main additives and the recipes, and of course like if we have a successful selection candidates and a very good design or the optimal. Okay, so now let's see what are the criteria that we take it usually to select like the best wells to be stimulated or by acid stimulation. The first thing is expecting gain. So when it comes, or what really matters at the end of the day, so how much hydrocarbon, how much reducing after the treatment design. So this is like, is it really promising to like to invest our money to do this or not? And then like identifying the problem by doing performance decline and formation analysis, formation damage analysis, to know the problem is about still water cut. They prefer not to do acidizing because we never know, it might be after acidizing the situation, it might get worse. And like some wells, it has been approved that some wells, they were producing, let's say 40% of water cut, and then this water cut increased up to like choosing the wells that have high water cut. For the sand production, I guess the same. It's always tend to be like the low priority if you have sand production, and start thinking about other solutions instead of doing stimulation. Permeability is this is exactly what's the most important thing. If you have high original permeability, start the stimulation with this well. Okay, then we have the treatment designs. The treatment designs, as we will see later in a bit of details, the volumes, treatment design that includes volumes, and what's the recipe that includes in that mud design, and the bump sequence. And then the field operations, as I told you, that sometimes you have the best well that is selected and the best treatment design, but the field operation, there are different techniques are being used to do stimulation acidizing. Like maybe most of you know them, is the bullhead or cold tubing. And there is kind of new technology using powder acid called stem sticks technique. And like in the following slides, we will see each element of the selection criteria, treatment design, and the field operation in a bit of details. Here, I would like to highlight something, that what is like, how can we say the job is successful or not? Okay, so let's say that there are two main categories, there are two main approaches that usually is being followed. The first one is like, does the incremental production pay out the treatment cost within a certain period of time? So this is like a commercial thing more than anything else. Okay, so they compare like the paid or the increment of oil or hydrocarbon that's being produced. Like, does it equal or better than for the the money that was, or the cost that was already paid for this job. So this is the criteria, the first criteria. And the second is, this is a purely technical point of view. Like, is the production rate after the treatment, is it greater before, after the treatment, is it greater than before the treatment? So sometimes we don't care about the like the money or something. We just care about the um, the rate is just bigger or not. Okay, so that's how we the two criteria that's being followed to decide the job was successful or not. Here we have this table in the selection criteria. At first you need to do like a data matrix and provide all the wells that you have and collect, as you can see here in this table, the production data and the completion data and the reservoir data as well. So you have here all the data that you have, and then try to build a good database and try to include all the wells that you suspect they are damaged and need to be produced. So once you collect all the data that you have, then you know you will start doing you will start to analyze these data, and you will start to convince your managers with that these wells are the best candidates for to be stimulated. So after data matrix that we have already built, then we start doing something called screening criteria. And the screening criteria, you will take all the parameters that have a big effect on the acid stimulation. Okay, so here I have just an example of them. You will take in your considerations the skin value and the permeability, if you have water cut, and the distance to free water level, and what is the gross thickness area. And then you will do something like a score for each element. For example, for the production rate, if the flow rate is lower than a specific value, okay, so you will give a score of 5. Otherwise, the score will be 1. The same thing for the rest of parameters. Let's say for the gross thickness, if the gross thickness, there's a specific equation for that, and you will end up like the higher pay zone, the higher score. For example, for the water cut, if the water cut is less than %, so the score should be higher than. If it's not, so the water cut will be a 10 as a score, and if it's like higher than 10%, it will be 1. Okay, maybe some of you are asking, why do we have these values and scores and stuff, or why these everything? Okay, by this method, it's not exactly like a standard method or a standard numbers or scores. It depends on the policy of the company. It depends on the in which organizations you are. And so maybe some of the companies are very strict, and they want the job, they want to be like higher probability of success, so they will make it very strict. Other companies, they will be more open, and the score would be like somehow different. But what really matters, if you have noticed in this in this table, is the damaged skin. So this is the highest score will be given if the permeability is higher than 10 and the skin is more than 2. Okay, so here the score will be 100, and otherwise, if you don't have this, so the score, the general score or the total score will not be high. So by this way, you took all the parameters that are needed to analyze the probability of success in terms of candidate selection. So now after you give a score for each well, based on all the parameters that we have talking about, so now you end up with well ranking. And the well ranking, so you have, this is the best candidate well to be treated, and this is the second well that it could be treated, and so on. And finally, you will, do something, the well selection. And then after that, based on the ranking, you will select the best wells to be stimulated. according to what you have like expected to produce after the treatment design, you can apply different techniques. You can use a simulation to predict what you're gonna produce. You can use simply the IBR curves. So you expect the new BWF, and you expect then you will expect the new productivity index, and according to that you will end up with this ranking. And maybe you can just give it to the managers, and they decide whether to go with the wells that have like high probability of success, like more than 60% or more than 70. It depends on the policy, and it depends on the company or the organizations that you are working with. So now we have done with the selection criteria. We propose to we assume that we selected all the wells, and now it's ready, to go to the second stage. At the second stage, here we have the treatment design. The treatment design involves volumetric calculations, recipe for formulations, and pump sequences and determinations. So the stage treatment is a common in classic stimulation to minimize the impact of unwanted secondary reactions. And the use of pre-flush and after-flush has proven to be like the best practice as understanding of, sand phase chemical interactions that would be definitely improved. So the volumetric requirements for the main stage treatment is determined first, while the pre-flush and after-flush volume are calculated subsequently based on these volumes. The treatment recipe usually includes iron control, or agent corrosions, like many additives. So this is one of the trickiest topics in the acid stimulation, because technically speaking, this is exactly what the main reason that you select different companies. Okay, so what are the additives that can provide? So this is one of the criteria that you choose one company from other. What kind of additives that provide? In fact, HCl and HF, formic acid, citric acid, all these are standard acids. However, the additives are different for each surface companies. So the design will be done according to the additives you, for like the surface company can provide. The first additives and the most important is the corrosion inhibitor. This is there's no acid treatment without corrosion inhibitor. The corrosion inhibitor is actually a group of materials together. So the main goal of corrosion inhibitors is to act as a barrier between the acid and the pipes, so the acid will not react with the casing or whatever pipe or tubing that you have or that you're using with. It's important to note that there are different corrosion inhibitors with different acid type. For example, there are corrosion inhibitors for HCl, and there is a corrosion inhibitor with hydrofluoric acid, and there's another works only for organic acid. So you may ask, what is the best way to choose the corrosion inhibitor for our treatment? So this basically by doing corrosion tests, as we've talked before, that we need to corrosion test, and we need to know what is the best type of corrosion that we are actually that's suitable our treatment. Another additive is a corrosion inhibitor intensifier. Okay, in some cases where the temperature is higher than 250 Fahrenheit, usually the corrosion inhibitors by itself is not enough. Why? Because of that temperature is like high temperature, and it needs assistance from other chemicals to enhance the corrosion performance. In fact, there are like two types of intensifier. They call it formic acid and potassium iodide. And I would like you to pay attention to this secret. We only use additives if we need them. Okay, so otherwise, they can just cost us money and nothing more. So, and here we are, the service companies do their tricks. I'm sure that like service companies were not like this, but this is exactly what they're doing. They always tend to add additives simply to get more more benefit from this. but we should always be careful with what type of additives, and do we really need to use like such kind of additives or not. So for example, if the temperatures is not high, let's say 150 Fahrenheit, we don't need to use like a corrosion inhibitor intensifiers and so on. Another one is the what we call it anti-sludge agents. Normally we apply it when we have, you know, asphaltene in your well. So you add this additive. This additive is in to eliminate the asphaltene and to you know, participate out of the formation. So that's why like the main goal of anti-sludge agents. And there are many other additives usually being actually used. And as I told you, it's according to what you have and according what, you know, according to the reservoir damage that is being, you know, accepted. Okay, and finally is the bump sequence. For the bump sequence, as we've talked before, that because of the high permeable zones, maybe the best situations that we'll do is not about injecting it from like in one shot. It's better to inject it in different stages. So this is might be the best situations, or we can actually use diverter, no matter if it's chemical or mechanical diverters, and this it could result in a better placement for acid treatment. And here we have the operational field. This is the third element in our triangle. Okay, there are different technologies could be applied to do the acid treatment. Okay, each one has got positive and negative sides. Okay, let's start with the coiled tubing. Cold tubing, the main, you know, the main positive thing, the main advantage of cold tubing is the, you know, you can control the volume. Okay, so sometimes you don't need to inject like a huge amount of volume, so you can just control the volume that you have, and also you can select the fluid to be placed in the specific intervals. So sometimes you have like producing from multi-layers, and these layers have got different permeabilities. Some of layers are acting as a vertical or as a vertical barrier, so they have a very low permeability, or some layers were damaged more than others. So you want to, the acid goes, it goes into the formation that is like highly damaged, instead of going to the easiest path for the acid, which is has got high permeability. So the coil tubing is a very good option to be used in our treatments. And also the coil tubing is good for the suitable long intervals and variable permeability. Yeah, that's what exactly, you know, this is the main important thing. um, the disadvantage of it, you know, if you have, or if you want to inject huge volumes, like if your volume is really huge, I don't know exactly how much, but it's gonna take time to inject all that volume. Okay, so it's not really recommended to do coil tubing if you have like a small amount of volumes. And I don't no need to say that is it's quite expensive compared to the other, you know, techniques. By the way, that honestly, I don't have experience in the field life, but the maybe other engineers for the one like for Schlumberger, or you know, they have like real practice of these technologies. But what I'm, you know, presenting now is like a general information, and this is the basic informations that, you know, every engineer should know about each technologies, and why do we choose, you know, cold tubing. Sometimes we don't need to do to choose cold tubing since it is expensive, and we might go to the other options, which is the ball head. We are simply in the ball head, we are injecting from the surface, and therefore large volumes, if needed, is to be injected. So the bullhead, it might be the suitable options for our treatment, and at least is not as expensive as coiled tubing, but it has, disadvantages, which is the exposure of the whole completion to the acid. So our completion, if you are injecting from casing, tubing, or whatever, so the it will be, habitats, it might, harm or react with our production strength. So this is could be a disadvantage of that. And also we need like too much pressure at serves. You are injecting from the serves, so also that could be, harms the integrity of the production string. And there's another thing, it's not written here. Another thing is the cleaning up. So with a bullhead, it's quite difficult, or it's more difficult than coiled tubing in terms of cleaning after doing the treatment. And there is a kind of new technology called stem sticks. Okay, this technology is kind of different technology. It's mainly about, powder. There's no like mud, but it's powder, and is being injected into the formation through, slick line or whatever. Okay, and when it reaches to the interval that is needed to be stimulated, the temperature increases to like very high temperatures, and then it enters into the formations. Um, the main advantage of it, that the acid is generated across the formations in a heated vapor state, and you can actually select the exact placement that you need to do, and then eliminates the contamination and dilution of liquid acid during the placement, and also it's low viscous vapor. So if you are talking about the damage after treatment, so this is somehow it eliminates the sort of damage that may occur after treatment. And also eliminates the use of, portable water if in conventional, acid blending, and eliminates the post acid flow back. There are like many things could be explained about stem sticks, but this is kind of new technology in at least for North Africa, and in my country as well. But it sounds to be is like took the, removed all the disadvantages that has been, proposed for the other technologies. So now I guess we have almost finished our presentations. We have already, talking about the how can we select our candidate wells, and what's the things that should be highlighted in the recipes, and finally what's the best technique that could be applied to do the stimulation. um, I think this is all. Thank you all for attending these presentations. And